Projectiles, type 6 bouncing. So these bouncing questions can come up in both the horizontal and the inclined plane. And we have to remember when we have any object bouncing off a surface, there's going to be impacts. And if we remember about our impacts, that what we have is minus e is equal to the new velocity over the old velocity. So that's always kind of the key to these bouncing questions. Okay, so let's have a look at the question that came up in 2001, question 3b. We have a ball, this time is dropped from a height of h onto a smooth inclined plane, so no friction there. The ball strikes the plane at P and rebounds. The plane is inclined at an angle of 30 degrees to the horizontal, and the coefficient of restitution of the ball and the plane is a half. And we want to know how far down the plane from P is the ball's next point of impact. And we have to express our answer in terms of h. So let's have a little closer look at this diagram here. So for setting up our table, essentially what we need to know is what is this velocity of the object as it starts off in its projectile path down the hill. So we have to work out what is that velocity after the ball has had impact with the surface. So just before the impact, what can I say? Well, if I look at the diagram, I'm going to have to resolve the velocity. So the velocity component is going down. So if I resolve that, I'm going to use a different colour pen for resolving your vectors always. We can see we have the velocity, parallel and perpendicular components. So again, that's our right angle triangle there. If I was to continue that line down, we'd have 30, 90, and we can see vertically opposite angles. So that angle 90 means this angle here has to be 30 degrees, which makes this side the opposite, this side the adjacent, and the original vector is the hypotenuse. So therefore the opposite is going to be h sine 30. Sorry, not h, I should say velocity. So the initial velocity, and then the adjacent will be v cos 30. So in other words, the velocity just before impact is going to be v sine 30 in the I direction, and that would be, and then minus v cos 30 in the j direction, because obviously when we're looking at the impact, we can see that's going to be positive. So it'll be the same direction in the x direction because it's going down the hill, but dropped is going to be negative in comparison to when it rebounds off the surface. It'll be positive. Okay, so therefore what is that if we simplify that? Well, that is b over 2 on the I direction and minus root 3 over 2v in the j direction. So we say after impact then, that minus e must equal v over u. And we were told that the coefficient of restitution was a half. And of course there's going to be no change in the I direction there. So the change is only in the, so I is conserved. So we're only interested in the j vector here, okay? So we have minus a half is equal to v, which is minus root 3 over 2 v over the new, sorry, I've written that wrong there. So I'm looking for the new velocity. So it's going to be minus e times u. So it's going to be minus a half times the old, which is minus root 3 over 2v. So in other words, this j vector up here is our old velocity. So therefore the new velocity after impact is going to be root 3 over 4v. So therefore our rebound velocity, once the ball hits the surface, so with the I being conserved, then that's going to be v over 2 in the I direction, and then our new velocity is root 3 over 4v in the j direction. However, what do we know about v? Well, if I go back up to the question, we can see it's dropped from a height. So that implies then that the initial velocity is 0. It's falling, and it's free falling, so therefore that's going to be acceleration due to gravity. And it falls a distance of h. So therefore, if I'm looking at what is v, well, I have ua and s, so it's going to be v squared is equal to u squared plus 2as. So that means that v is going to be equal to the square root of 0 squared plus 2gh. So in other words, the square root of 2gh is v. So therefore, if we simplify that, my rebound velocity then has to be the square root of 2gh over 2 in the I direction, and the square root of okay. So for that rebound velocity then we were getting 5 for working out what v was, and 5 for getting out our equation for our rebound velocity in terms of our I and our j. Okay, so what we want to look at next then is basically how far down the plane from P is the ball's next point of impact. So essentially what we're looking there for is S in the X direction. So we need to set up our table for U, A, V, S, T, the X and the Y direction. So for our U in our X direction, that's our I component here, so it's going to be root 2GH over 2. And then in the Y direction, we can see it's root 3 over 4 times the square root of 2GH. Our acceleration, well, we're going down the hill. So again, if we're resolving our gravity, so G is down. So we need to resolve that in the perpendicular to the plane and parallel to the plane. So again, we can see if we have 30, 90 in this angle here, we have vertically opposite equal angles. So therefore this angle up here must also be 30, which makes this side the opposite and this side the adjacent. So therefore that is going to be, if I zoom in on that diagram, the opposite is always the hypotenuse times sine theta. So it's going to be G sine 30, and the adjacent will be the hypotenuse, which is G times cos 30. So again, that means if we go to our table, our acceleration in the x direction, we can see is in the same direction as the initial velocity, so that's going to be positive for G, but it's in the opposite direction for the adjacent to the initial velocity for that ball once it's bouncing off the surface, and therefore we have to give a negative sign to gravity in the y direction. So G sine 30 is basically G over 2, and minus G cos 30 is going to be minus root 3 G over 2. So therefore v is going to be u plus at. So in the x direction, that's going to be the square root of 2gh over 2 plus g over 2t. And in the y direction, that's going to be root 3 over 4 square root of 2gh minus root 3 over 2 gt. And then s is ut plus a half at squared. So in the x direction, that's the square root of 2gh over 2t. And then plus a half at squared is going to be g over 4 t squared. And in the y direction, that's root 3 over 4 times the square root of 2ght plus a half, so it's going to be root 3 over 4 gt squared. So now we have every equation we could possibly need for this question, but we're looking for the range. So for the range, we're looking for s of x. So if we look at the equation here for s of x, we can see we're clearly going to need our time of flight. So we know that on landing, our time of flight is going to be equal to 0 for s of y. So if we take our s of y equation, we have root 3 over 4 times the square root of 2ght minus the square root of 3 over 4 gt squared. And if I factor out, if I multiply across by 4 there and divide across by root 3, I'm left with the square root of 2ght minus gt squared. So taking out t as being common, I'm left with root 2gh minus gt equals 0. And therefore I can say, well, t is equal to 0, and that's clearly at the start, because at the start the ball is just after bouncing off the surface, so sitting on the surface. And then if I let root 2gh minus gt equal 0, well, that gives me my time of flight is equal to the square root of 2gh over g. So now I have the time of flight. I can work out then, well, what is my range by subbing in for t. So if we sub into our equation, so we can see s of x is the square root of 2gh over 2 times t, the time of flight, plus g over 4 times the time of flight squared. So that gives us the square root of 2gh over 2 by the square root of 2gh over g plus g over 4 times the square root of 2gh over g squared. So if we simplify that, we can see we have the square root of 2gh by itself, so that just gives us 2gh over 2g plus g over 4. And if I square the square root of 2gh, I get 2gh, and if I square g, I get g squared. So we can simplify that, so 2g goes into 2g, and we have g will go into g squared as well g, and then 2 will go into 4. So that basically leaves us then with h plus h over 2. And therefore the range in terms of h is 3h over 2. So we had 5 for getting how far down is the next impact going to be, and 5 for our time of flight. So in other words, 25 overall.